Welcome back. We will look at patterns in this module. So what are patterns? We all know what a pattern is. It's some ordered relationship amongst artifacts. Often you see it occurring in multiple places. The first wide scale use of this term happened in architecture, as in building architecture, by a great thinker called Christopher Alexander, who in his seminal work in 77 and 79 talked about patterns that you encounter in buildings and towns and in construction. Very quickly the software community picked up this concept because they seem to encounter patterns very frequently in their activity, which is also a construction activity. They construct software, and one of the earliest references was by Beck and Cunningham in 1987, where they talked about patterns in object-oriented design. The seminal work on this topic is in 1994 by 4 people: Eric Gama, Richard Helm, Ralph Johnson, and John Vlissides. This is often called the Gang of 4. So GOF. So you will hear the term GOF book or GOF patterns. They wrote a book talking of design patterns, elements of reusable software. It came out in 94. So what is a design pattern? I checked on Wikipedia how they try to define it. So there is a general reusable solution to a commonly occurring problem within a given context in software design. So there are 2 important things here: commonly occurring problem. So you encounter similar scenarios in multiple problems, and for each of them you would like to use or reuse a solution that you have found earlier. So reuse is critical, and commonly occurring recurring problem is critical. So when we say reuse, what are we trying to talk of? Are we talking about reuse of code? So code reuse has been a major topic of interest in software community, and some interesting studies done on this. Trying to force or trying to achieve code reuse hasn't been very successful in the software industry, but architecture reuse has been very successful. So the way you have solved a particular problem, you solve another problem in a similar way. What is the similarity between these two? The pattern, the architecture, the way that was constructed, you construct similarly. Code reuse hasn't worked. So there is a folk theorem on code reuse actually. So somebody asked, when will code get reused? Apparently this is a function of the specification size and the code size. If I am talking about a component, let us say, which requires X amount of time to describe what that functionality is, and it is going to take Y amounts of time to build it, Y by X is a indicator of whether that component is going to be reused or not. Classic example is a database engine or an HTTP server. These don't take too long to explain. A database engine requirements I could possibly present in 20 minutes time, but try to build it, it's going to take 10% years at the minimum, and often you will have to do lots of innovations and research. Not all the ways of building it are available in literature or in a textbook. So if this ratio is of a certain side, then it gets reused. User interface widgets get reused. They are easy to describe. All that you need to say is, okay, there is a radio button, if you click, I want the thing to change color. But try to build it, it's going to take much longer to build it. So that's about code reuse. But here we are talking about not code reuse, we are talking about architectural reuse. So what does Wikipedia say? It is not a finished design that can be transferred directly into a code. It is basically a description to solve a problem that can be used in many different situations. It is essentially a formalization of best practices. This problem, if you solve using this kind of relationships amongst its components, then you will get these properties. This is the best way to solve this problem. That is what a design pattern is. What is an architecture pattern? If you remember my earlier lecture, I said I am going to use this term interchangeably, and only the difference that I am going to impose on this is, in architecture I am going to look at components and their relationships. In design I am going to look at objects, classes and their relationships. This is my working definition. You are not going to fight on this. So, if you look at our textbook Bath, Clements and Caseman, Software Architecture and Practice, 3rd edition, they define an architecture pattern. And how do they say? What it is? A package of design decisions repeatedly found in practice, has known properties. What are properties are we talking about? Quality attribute properties that permit reuse, describe a class of architectures. Okay, now let us move on to tactics and patterns. We already know what tactics are. Do you remember? We talked about, if I am interested in certain quality attributes, how do I achieve them? I can increase concurrency to improve my performance. I can add more resources. I can put an intermediary. These are the tactics that we talked about, right? Now, patterns also talk about achieving certain quality attributes, but the point is patterns are more complex than tactics. So, basically a pattern packages several tactics. So, tactics address a single architectural concern, they solve one aspect of it, and when you actually apply that aspect, you may get a side effect resulting in some other quality attribute requirement being not met. So, then you apply another tactic to compensate for the loss. So, you apply tactics one after another, a multiple set of tactics, and then you can build a pattern. So, what we are saying, to repeat myself, tactic is addressing one quality attribute, pattern basically packages tactics and it achieves a balance amongst the various architectural forces that may be there in the requirement. So, how do I define a pattern, an architectural pattern? This is again from our textbook. We talk about a context in which the pattern occurs, a situation that occurs, a problem that recurs, that has a context, then what that problem is and the solution. So, context, problem, solution triple defines what an architecture pattern is. This is trying to formalize. This lecture is an informal introduction into patterns. So, I am not going to dwell too much on this way of describing the patterns. But one quick point I want you to remember, when I am solving a problem, when I am cutting a design for a solution, often I may end up using more than one pattern. So, a solution will probably involve multiple patterns to fully address all the requirements that the problem demands. Even though we said a pattern is about a solution for a particular problem, but the real life problems may actually package multiple patterns, and a pattern packages multiple tactics. So, here is an incomplete list of patterns. I call it an incomplete list because it is an incomplete list. So, these are examples, some of these you must have already heard of. You know, multiple MVC, model view controller, is a very well known pattern, design pattern, architecture pattern. Client server, of course, one didn't know it is a pattern. Service orientation, publish, subscribe, map reduce, right? It is the fashionable thing these days. I am going to talk about some of these patterns and explain them in a little detail. Again, as I said, an informal introduction to patterns. So let us look at the MVC pattern. It is one of the oldest patterns. It has been invented by the Smalltalk community. Conceptually, it is very simple. I have a computation that is happening and I want to present the results of the computation to my user. For example, there may be a simulator of a reactor or a gas turbine or a boiler, and I want to show its temperature. Now, sometimes I will increase the gas, the petrol going into the boiler, and then the temperature goes up. So there is a user, he is manipulating the controls and he is seeing the temperature. Suppose there are multiple ways or need to show the temperature. Sometimes I want to show it as degrees centigrade, I may want to show it as maybe a meter, or sometimes I may want to show it as a mercury column going up or down. So there are multiple ways to show the same temperature. So the simulator is computing the temperature and I want to show it in multiple different ways. What is the simplest way to build such a system? So I have actually various views possible for the same computational model. That is when you apply the MVC pattern. So the user interacts with the controller sends the signals to the model does the computation with a new set of parameters and updates the views that are there, one or more. So this is an MVC pattern. Okay, this is publish subscribe. This is again very interesting. Let us say I have a railway, Indian Railways, talking about their timetable, which train starts when and where, the scheduled timetable, and then I have the various airlines also talking about their schedules. So each one of them is publishing their schedules, and then there are websites like makemytrip.com or Ixigo or whoever, they want to make these schedules available to the customers that they have. So they need, the people here need to know the values that are published here. Indian Railways shouldn't be bothered about who are the people who are going to get this information. This set may change dynamically, but whenever a update happens here, whenever Indian Railways changes their schedules, all the subscribers need to be informed. Subscribers can join and leave dynamically. Publishers can update without bothering about having to notify independent subscribers or having to keep track of all the subscribers. So it is very simple to achieve this kind of asynchronization or desynchronization. So basically I build a object component where the publishers can publish and there are subscribers who are subscribing to this. So this is the publish subscribe pattern. Pipe and filter. This is again a very simple but very interesting and known pattern. So we are talking about computational components which are called filters. They take in certain input, perform a computation and push it out. It goes into another computational component which does further processing and again push it out. This is a pipe and filter pattern. Where do we encounter it? Compilers. Suppose I take a compiler. So how does a compiler work? It takes a certain program and then it does parsing, right? It checks whether it is syntactically correct or not. Then it may do some semantic processing. It will try to resolve certain addresses that are there, some forward references, backward references or whatever. Then it may do some code generation. It may do some optimization either before this or after, and then finally it throws it out. So, the input source program goes through a sequence of stages before it is thrown out. Another easier example is a database engine. You type an SQL query, it goes through a parser to check again for its correctness, then it will check for whether the user who has typed the query has the permissions to make this manipulation on the data or not. Then it may do some optimizations on the query, it will do an access path selection, how do I compute the query, whether I use an index or not, and finally I execute the query and send it out. So again you see I am processing the input in stages. So this is a pipe and filter architecture or a pipe and filter pattern. This is the client server pattern, which is very simple. We have a set of servers which have some services. For each server there may be more than one client. The servers advertise their services, the clients connect to the server through a network and they can get the service. The client knows who the server is. So the internet is a classic example. So I know the IP address and I go to the server and get my service. This is the client server pattern. There is a broker pattern. This is very interesting again. Basically I have an intermediary here between the client and server. When the client sends a request, the broker figures out where the request should go and then get the reply from the server and then give it back to the client. So I am having a proxy in between. So this pattern has multiple uses. The server, the client need not know who the server is exactly. The broker can decide. The broker also can enforce certain rules on the kind of interaction that may happen. Very typically in an educational institute we encounter this, where we put a proxy server for internet access. The proxy server is going to pinch the client access in more than one way. So this is a broker pattern. So when my requirement is to decouple the client and server or enforce certain business rules, I can use a broker pattern. This is a small table which I picked up from our textbook reference. It is also available as a technical report from the Software Engineering Institute's website, which talks about which are the tactics are here in this row that are being used in which design pattern. I won't try to explain this, but this is just an indication. Those of you who are very keen on this body of knowledge can actually go and read the text report or go and read the book, textbook. So it says in the broker pattern I am using large number of tactics which will increase cohesion, which will reduce coupling and defer binding time. All these are under modifiability. So the broker pattern will give me modifiability quality attribute by implementing these tactics. It is a very interesting table. Actually you can construct such relationships for all design patterns and you can publish a paper out of it. So what do I want you to do as homework for this? Whenever you encounter a solution, look for patterns. Somebody gives you an architecture saying, look, I have built this, I have designed this. Somebody gives you a design. This is my design for your problem. Then you ask, hey, is it following certain design pattern? Is it a pattern that I already know? Look for patterns. Counterpart of that is when you need to solve a problem, when you need to design, when you need to architect a design, see if you can use one of the existing standard design patterns. Remember, to actually solve the problem, you may need to take the pattern and modify a bit. It is only a template. or you may have to use more than one pattern, but nevertheless see if any of these tools that you have, they can be used in solving your problem. Thank you.